Hello everyone. In this short video tutorial, we are going to look at the atom. And specifically, we want to know what the mass number is, what the atomic number is, how you determine the number of protons, neutrons, and electrons that you find in an atom, and finally, we want to know how you determine the number of electrons that you find in the valence shell of an atom. So I've got the periodic table of the elements up. And you'll notice that in the periodic table of the elements, each atom is going to have two numbers associated with it. So let's take a look at aluminum. For aluminum, you see a number here that's 13. And down here, you see another number that's 27. You'll notice that 13 is followed by 14, which is followed by 15, which is followed by 16, etc., etc. What that number indicates is the number of protons that you have in that atom. So we'll write it down here. Aluminum has a number 13. And that number 13 is called the atomic number. And the atomic number is simply the number of protons that you have in that atom. The other number, which is 27, is the mass number. And the mass number is the number of protons plus neutrons that you find in that atom. So if we have 13 protons in aluminum, and if we have a mass number of 27, that means 27 minus 13 is 14, so we have 14 neutrons in aluminum. So this very simply tells us how we can determine the number of protons and neutrons found in the atom. But what about electrons? Well, all these atoms here on the periodic table are neutral. They don't have a positive charge. They don't have a negative charge. If they did, they would be ions. But they're not ions. They're just neutral atoms in the periodic table. So that means if we know that protons are positive and electrons are negative, then the number of protons equals the number of electrons because we have neutrality. So aluminum also has 13 electrons found within it. Now, a second ago, I mentioned ions. What if we had aluminum, but aluminum wasn't neutral? What if we had aluminum and it was aluminum that's, say, 3+? That means that aluminum 3+ is an ion, and it's going to have 3 more protons than it does electrons. So the number of neutrons stays the same. We still have neutrons equaling 14. The number of protons still remains the same because we're not talking about isotopes here. We're talking about aluminum 13. Yes? So it has 13 protons still, but we have to have 3 more protons than we do electrons. So that means aluminum 3+ is going to have 10 electrons because 13 minus 10 equals positive 3. Now, we can also have a negative ion. So instead of having aluminum plus 3, what if we had aluminum that's, say, 2-? That means we now have more electrons than we do protons. So again, we still have 14 neutrons that's found within aluminum 2- ion. We also are still going to have 13 protons because that's not going to change. It is still aluminum, and 13 is what makes aluminum, right? The number of electrons now has to be more than 13 by 2. So the number of electrons here is going to be 15. So now 13 minus 15 equals -2, and that's exactly what we have. So finding the number of electrons, protons, and neutrons is a relatively simple task. Let's take a look at another one. If we look on the periodic table, let's take a look at oxygen. Oxygen has an atomic number of 8, and it has a mass number of 16. So here is oxygen with an atomic number of 8 which is also the number of protons found within oxygen, and a mass number of 16, which is the number of protons plus neutrons found in oxygen. So once again, if we have a mass number of 16 and an atomic number of 8, that means that the number of neutrons we have is 16 minus 8, which equals 8 neutrons. We also know that oxygen is neutral, which means the number of protons equals the number of electrons, which also equals 8. So here's another question, though, for you. A moment ago, I mentioned valence and valence shells. Well, let's go back again to the periodic table of the elements, and then we're going to revisit oxygen. If you take a look at the periodic table of the elements, you'll notice that the table is grouped. So right here, this is group 1. This is group 2. We're going to skip over the transition metals and go right here to group 3, then group 4, then group 5, 6, 7, and finally 8. What those numbers indicate is that if you're in the group of that number, then you will have that many electrons in your respective valence shell. So if we come here to oxygen, oxygen is 6. It's in group 6, which means that there are 6 electrons in the valence shell of oxygen. The same is true with sulfur. The same is true with all of these elements that are found within this group. So let's go back to the picture that we were just about to draw. Once again, let's take a look at oxygen. So again, oxygen has an atomic number of 8 and a mass number of 16. Remember, atomic number equals the number of protons, and because oxygen 16 is neutral, it also has the same amount of electrons, which is going to be 8. Now, when we talk about an atom and we talk about the structure of an atom, we know that the atom has a nucleus, and found within the nucleus are the atom's protons and neutrons. And then surrounding the nucleus are going to be our shells that contain electrons. The maximum amount of electrons that the first shell can have is 2. The maximum amount of electrons that the second shell can have is 8. And if you had a third shell, then the maximum amount of electrons the third shell can have is also 8. Well, when we talk about oxygen, we don't have 16 plus 2 equals 18 electrons. We have 8 electrons. And so let's draw the oxygen atom. So we're going to have our nucleus. And then surrounding the nucleus, we're going to have our first shell of electrons. And there's going to be 2. Because remember, the maximum amount of electrons we can have in the inner shell is 2. So I'll put an electron here and an electron there. Then we have to go to our next shell, or our second shell. Well, we've already used up 2 electrons, which means we only have 6 more left. Because remember, oxygen is going to have 8 total electrons. We've already used up 2. So now we're going to put 6 electrons in this outer valence shell. So 1, 2, 3, 4, 5, 6. And that's it. Now remember, what group is oxygen in? Oxygen is in group 6. Okay, I hope this helps. After this discussion, we're going to move on to isotopes. Thank you.